Hi, hello, vanakkam, and welcome back to yet another episode on Little's Law YouTube channel. So today in this video we are going to see about what is Little's Law, how are we going to use Little's Law for the workload modeling, and what is the problem in using the Little's Law and how are we going to fix it. This is going to be very interesting today. So please do watch the video till the end. And if you have not subscribed to our channel, please do subscribe to our channel, like, comment, and ask your questions in the comment section and share the video with your friends. So first, let's see what is performance testing. How does we get into the performance testing? And then we will see about some of the important metrics that we deal with performance testing, which is related to Little's Law. So firstly, performance testing is the other non-functional testing or the load test is used to measure the performance of an application in terms of its user load handling capacity, its sustainability, and the responsiveness of the server and the application. So in today's world, we all know that the client or the one who develops the application is keen on the non-functional experience, that is the user experience of the application. And most of us will either terminate the page or move out of the page, or we definitely do not use that application if the response time is more than 10 seconds. And this will directly impact the revenue of the company. So to meet the user expectations and to avoid any performance or any non-functional related issues, all the organizations are concentrating on the responsiveness of the application along with the user load and the capacity of the website or the application. So now let's move to the important metrics that deals with performance testing and which are related to the Little's. So the first one is the user load. So what is a user load? So the load applied to the server during testing in terms of virtual users. So the number of users we use for testing is called the user load. And then second comes the response time, which is the major and the important factor of performance or any load test. So what is the response time? So the time taken by the system to respond to the user request, and this includes the network latency. And next comes the iteration. So the user navigates on the website. For example, he lands into the landing page, and then he navigates to the home page, or he logs into the application, and then he searches for a product and he orders a product, and in case some users they add the items to the cart, and before ordering they might log out. So there are like multiple iterations, but it is a series of actions until they close their last activity in their transaction. And then next comes the transaction, which is the fourth one, which refers to the user's activity on a page. For example, logging in to the application is a transaction, applying for a product or adding a product to the cart or ordering the item is a transaction. And next comes the think time. So what is think time? So the time taken by a real user on a web page before submitting the request is think time. And next comes the most important of all, which is the pacing. So what is pacing? So the pacing is the delay time which is added by a performance tester between two iterations to achieve the defined load. So these are the 6 major factors or the metrics which we handle with performance testing and the Little's Law. The first one is the user's load, and the second one is the response time. The third one is the iteration. The fourth one is the transaction. The fifth one is the think time, and the sixth one is the pacing. So before we move on, let us have a little introduction to Little's Law. So in fact, our YouTube channel's name is Little's Law. It is basically taken from the person John Little, who has come up or who had initially published a paper in which he described the queuing theory by a new law which later termed as Little's Law. And he formulated 3 basic terms, which is the first one is the average number of customers, and the second one is the arrival rate, and the third one is the average time spent by a customer in the system. So this channel, so we have named the channel in remembrance of the great John Little. So now let us see what is the Little's law statement tells us. So now let's see what is Little's law. So Little's law is a mathematical formula which is used in performance testing and workload modeling to estimate system performance and behavior under various workload scenarios. And this relates the number of tasks in a system to the arrival rate, which is the average arrival rate, and the average time it takes to complete a task. So what's the formula for Little's law, which is n? N is the average number of tasks in the system, and lambda is the average arrival rate of tasks, and W is the average time it takes to complete a task. So we calculate the average number of tasks in the system by multiplying the average arrival rate and the average time it takes to complete a task. So it is N is equal to lambda multiplied by W. So to use Little's law for workload modeling in performance testing, we need to have data on at least two of the three variables, and we can use the formula to calculate the third variable, which can help us to predict how the system will behave under different workload scenarios. So let's see the first example. So in the first example, we have the following data for a web application. So the average number of concurrent user on the site is 500. So here the N is 500, and the average time it takes to complete the transaction on the site is 5 seconds. So now we will use the Little's law to calculate the average arrival rate of transactions using the formula. So initially we saw that n is equal to lambda multiplied by w, and now we have n and w, so we can calculate the lambda. So lambda is equal to n divided by w. So now we have got lambda is equal to 500, which is the average number of concurrent users, divided by 5, which is the time it takes to complete a transaction. So we can handle 100 transactions per second. So for every 5 seconds, we can complete a transaction. So at the end of the 500 second, we can complete 100 transactions. So this means on average, the web application is handling 100 transactions. And with this information, we can predict how the system will behave under different workload scenarios. So now let's see another example. So this is followed by the same one. So in case if we increase the number of concurrent users to 1000, we can use the Little's law to estimate the impact of system performance. And for that, let's see. We have the number of users, which is n is equal to lambda multiplied by w, which is the average time taken to complete a transaction. So now we have the lambda, which is the throughput, and then we have the w, which is the average time. So we can calculate how much users can be handled. So now we have got n is equal to 100 multiplied by 5, which is n is equal to 500. So this means that if the number of concurrent user doubles, the average number of transactions in the system also will double. And this can help us to estimate the system's capacity and identify the potential performance bottlenecks. So in summary, Little's law is a powerful tool for workload modeling in performance testing. So now let us see another example. This is going to be a little detailed and a real-time example. So in this example, we will see how much response time, how much think time we need to add, and how much pacing we can add, and how many iterations we can achieve. Okay, so this is a simple table which we normally use to find this. So in this example, I'm just using just only one set of transactions. Say for example, if this is going to be a shopping cart application, and then in that case you're going to the landing page, and then you are logging in, and then okay, yes, let me just write it here. So it is going to be a landing page, and then this is going to be your login transaction. And once you log in, you visit a page, you start to search for item, you start search, and then you search for another item, and then finally you pick an item, you add to cart, and then you check out, and then finally you log out of the application. So this is how normally our transaction goes. And here we can see the response times. So this is just an example. So for example, the landing page takes 3 seconds, the login page takes 7 seconds, the search page 5, and the next search again takes 5, and then adding to cart takes 2 seconds, and then checkout takes 5 seconds, and finally the logout takes 3 seconds. So totally one particular script for one user. So here we'll see, so one user for one iteration, the total response time is going to be, let me just drag it out, okay. It's going to be, let me add all these, and so here we can see for one iteration we have 30 seconds as total response times. So there is no think time or no pacing that has been added. So without any delays we can achieve this in 30 seconds. So now for example, if you are using 100 users to achieve this, so how many iterations we can achieve in 1 minute? So for users is going to be 100 users in how many iterations for 1 minute. So to know that, so what we can do is, the formula is going to be very simple. So we are going to calculate for 1 minute. So 1 minute has 60 seconds, and we are achieving, so here the serving time, so which we already saw, which is 30 seconds. So I'm just giving it as 30 seconds here, and we know the value n, which is the number of users. So I'm going to divide that here. So now what we did is we have, so we'll need to multiply the arrival rate or the processing rate with the number of users. So if we are able to iterate 2 times in a minute, so with 100 users we can complete 200 iterations in a minute. In 1 minute we can complete 200 iterations, because we can achieve 2 iterations in a minute. So how many iterations in an hour? So 1 hour consists of 60 minutes, so which means 200 multiplied by 60. So in 1 hour we are going to achieve 12,000 iterations. But what is our expectation? Our expectation is 2,400. So to achieve 2,400, what is going to be our, so now we have to introduce the think time and the pacing between each iteration. So let's see how much think time and pacing are we going to introduce. So let me just do a copy of this in our next table. So I'm adding the copy here. So let's make some calculations in here. So what I'm going to do now is I'm going to just reduce the number of iterations. So to achieve 2,400, what is going to be the iterations in a minute? So let me reduce this 200 to half of it. So which means every user, so one user will iterate 1 time, so which means 100 users will iterate 100 times in a one time in a minute. So which means we are going to achieve 100. So if we are able to achieve 100 iterations in a minute, then we can achieve 6,000 in an hour. So we still want to come down because we need just 2,400. So let me just bring it half of it. So when we are bringing it to 50, still we can achieve 3000. So let me just bring it to 40. So we have achieved 2400. So now let's go back to the user. So we can't touch the users, so let's don't touch the users. So if we want to iterate to 40 times, so we will have to increase the response time, right? So let me just move this to the next page here. So now here we have changed the iterations. We are able to find the iteration. So this is the iteration we have to get here. So already I told you we should not touch the users. So let's go back to the total response time. So we have to increase the total response time. So let me increase the total response time. So let me double the total response time. So if I'm okay, so now we have found here, so we should change the iteration to 40. So if we have achieved 40 iterations in a minute, then we can automatically reach to 2400 hours, 2400 iterations in an hour. So what we're going to do now is we'll have to increase the total response time. So let me increase the total response time to 60. So if we are able to achieve a 60 seconds of response time, then automatically the iterations comes down, and in turn it reduces the iterations. But still we haven't achieved the 2400. So let me increase it to double it. So now we can see when we were able to achieve 120 as a total response time for one user for one iteration, then here we were very close. So let me still increase it to 150, and yes, so here we can see that the response time, when it is 150 as a total response time for one user for one iteration, we can achieve for 1 minute for 40, and then for 1 hour it's 2400. So what we'll do now is we will add the think time. So the think time here is going to be, let me add it as 20, and then another 20, and then another 20, another 20, 20. So this is going to be the same. So before we add for the last iteration, because this 20 seconds comes after the page. So for example, so how it will be is, let me add a space here. So I'm adding insert one row above. So the same way I'm going to add another row. So just adding another row, then another row here. Sorry, let me add another row. Insert one row, and then let me add another row. Okay, so we'll add the response time here. So we will have to achieve 150 as a total response time. So let's adjust. So far we have 30 as a response time. So we'll have to add 20 seconds. So let me add 20. So let's do the change here. So let's add 20 and another 20, another 20, 20, 20, 20. And finally, so here we have achieved already 150. So what we can do now is, let us reduce it to 15 seconds. And still we have 30 remaining. So we'll add the 30, and finally we can see that we have achieved 150 seconds. Okay, so let's now go back here, and we will achieve and we will make all these changes, and finally we will try to come up with the final set of change, and then the 30 seconds. So here we started with a very basics level of transactions, and finally we have achieved our iterations which we required. Also we have found how much think time we need and how much pacing we needed. So with this I'll come to an end. So we will see with another interesting example in our next video, where we will find for a web API or for an API application, because API comes up with a different set formation. So we'll find out how to find the pacing and think time in that video, in our next video. So please do subscribe and please watch our channel. I will share the link of this file so that you can use this for your purpose, and then we'll have another separate video for multiple scripts. So that I definitely believe this video will be very useful. So please do subscribe to our channel and don't forget to comment your questions and feedback in the comment section. Until I meet you in another interesting video, bye from Little Slaw.